The while loop is used as the conditional loop. It's used when you want to repeat an action, but ahead of time you don't know how many times you're going to repeat the action. You just keep going until something happens. And so the general form of the while loop is you start with the reserved word while, then you have a condition. This is an expression that is conceptually true or false, and then you have an action. So the way it works is you start by evaluating the condition. If the condition is true, then you execute the action. So it starts out exactly like the if, but then you go back and you evaluate the condition again. If it's still true, you execute the action again. And then you go back and you evaluate the condition again. If it's still true, you execute the action again. And then you go back and you evaluate the condition again. If it's still true, you execute the action again. Then you go back. So I'm trying to point out that somehow you've got to get out of that. So something eventually in the action has to change something in the condition so that it becomes false and you get out of the loop and you go down to whatever happens after the while loop. Otherwise, if the condition is always true, you have what's called an infinite loop. So it's infinitely going to evaluate the condition if it's always true and keep executing the action. In MATLAB, you use Control-C to break out of an infinite loop if you have one. It's important to understand that since the condition comes before the action in a while loop, it's possible that the very first time you evaluate the condition is going to be false, so the action is not going to be executed at all. So again, with the while loop, it's possible that the action will not be executed at all, and that's important to understand. So the while loop is used when ahead of time you don't know how many times you're going to repeat the action, but a lot of times you end up wanting to know that. And so if you want to know how many times you repeat the action, you have to count it yourself. So you have some kind of a counter, which you start at 0, and then somewhere in the action of the while loop, you add 1 to the counter. You increment the counter by 1. So it could be in the beginning, could be in the middle, could be at the end, but somewhere in the action of the while loop, you add 1 to the counter. So every time the action is executed, you're incrementing the counter by 1. So that counts how many times the action was actually executed, including possibly 0 times. So if you get out of the while loop and counter is still 0, then that means that the condition was false to begin with and you didn't execute the action at all. So sometimes that's important to know it. So after the while loop, presumably you counted for a reason, you're going to do something with that counter. A really important application of while loops is error checking. So when you're prompting the user for some input, there's almost always a valid range of values. And what you should do is use a while loop to keep prompting the user, reading in the value, and checking it until the user enters a value that is correct. And this is called error checking. So the general form of a while loop that error checks starts by prompting the user for a value and reading it in. And then basically you say while the value is not in the correct range. So if that's true, the user didn't enter something that's valid. So the action is to print an error message and prompt them again. So then we go up and evaluate the condition again while the value is still not in the correct range. So if the user once again didn't type in something that's valid, print an error message, prompt the user again. So we keep going in the action as long as the user is typing in incorrect values. The way we get out of that is when the user actually does type in something that's valid. So that gets us out of the loop and we'll actually use the value that they entered. So it's important to see that we're prompting the user and reading in the value before the while loop and also at the end of the action of the while loop because we need a new value to check every time we evaluate this condition in the while loop. Now remember that it's possible that the condition will be false to begin with, and that's actually what we hope for in this case. We prompt the user and read in a value while it's not in the correct range. So if the user typed in something that's correct right away, then we'll skip the while loop entirely and just go ahead and use the value. So that's what we hope. Prompt the user, they type in something that's correct, we go ahead and use it. But if they do type in something that's incorrect, we're going to keep printing an error message and reprompting until they finally do type in a correct value. So that's a really important application and something you should always do whenever you're prompting the user and reading in values. Here's an example. If I wanted to prompt for the radius of a circle, that should be a positive number. So here I'm prompting by saying enter the radius of a circle and reading that into a variable radius. And I say while radius is less than or equal to 0, so neither one of those makes sense if it's negative or 0. So I'm just going to combine here in the prompt and the input the error message and reprompting. So I'm going to say invalid, enter a positive radius. So as long as the user is typing in negative values for the radius or 0, it's going to keep repeating that invalid enter a positive radius until the user finally does type in a positive value. That will make the condition false and get us out of the while loop. And then once we have a valid radius, we'll go ahead and use it to calculate the area of a circle and then print out the result. So again, there's almost always a valid range of values. In this case, a radius should be a positive number. So we use a while loop to make sure that we get a positive number from the user. To error check for integers, basically what you can do is you can prompt for an integer, you can read it in, but if the user typed in a real number, not an integer, and then you try to round it or convert it to an integer type or something like that, if it was a real number to begin with and you round it, then it's not going to be the same as the original number. If it is the same, then that means the user typed in an integer. So if you type in an integer and round it, then it's going to be the same value. So basically what we need to do here is to prompt the user to enter an integer and then convert that, in this case, to the type int32, or round it. Again, same idea. So now I have two variables, input num and num2. While they're not the same, that means that the value of input num was a real number to begin with. So while they're not the same, I'm going to reprompt for an integer and then convert that to int32. So since my condition uses both variables num2 and input num, I need to have new values in both of those variables to check. So when the user does type in an integer and we convert that to the type integer, it's not going to change, so num2 would be equal to input num, and that would get us out of the loop.